All right, so lesson 2 is on finding intercepts and a little bit more on those quadratic functions that we started last time. All right, so finding intercepts. This is pretty easy. We've talked about this before. So for any equation, a line, a parabola, whatever, if I'm finding the x-intercept, I plug in 0 for the y value. If I'm finding the y-intercept, I plug in 0 for the x value. Okay, so if I want the x-intercept, like I just said, I plug in 0 for y, and I solve the equation. So I have 0 equals 4x minus 6. I get 6 equals 4x. So I get 6 over 4, which is the same as 3 over 2. All right, if I want the y-intercept, I plug in 0 for x. So I get y equals 0 minus 6. I get y equals negative 6. Okay, these are not vertical and horizontal lines. They look like it when you say x equals 3 over 2 and y equals negative 6. They're points. So what I typically have you do is if it's an x-intercept, I have you write it as a point. I have you write 3 over 2, 0. Because we plugged in 0 for the y value to get a 3 over 2 for x. And for the y-intercept, we plugged in 0 for the x value to get negative 6 for the y. So 0, negative 6. So it doesn't matter. It doesn't have to be a line. In this case, we have y squared equals 16 minus x. Does any of you know what shape that is? It's a parabola. Does it open to the right or to the left? Ah. Yeah, tricky. It actually opens to the left. So if I find the x-intercept, I plug in 0 for the y, so I get 0 equals 16 minus x, so x equals 16. So again, that's the point 16, 0. If I find the y-intercept, I plug in 0 for the x, so I get y squared equals 16. So when I take the square root, I get plus or minus 4. So that means I have 0, 4, and I have 0, negative 4. Correct, I have 2. So the reason I knew it opens to the left is because if I have 16, 0, that's way out there. But 0, 4, and 0, negative 4 are there. That's a parabola that opens like that. That's kind of tricky. Not good graphic. It's kind of a review of our conic sections from way back when. All right, so I have y equals 2x cubed minus 4x squared. So again, if I find my x-intercept, I plug in 0 for the y, so I get 0 equals 2x cubed minus 4x squared. And I solve equations that look like this by pulling out the GCF. So what's the GCF in this case? 2x squared, right? So I'm going to pull out 2x squared, and when I do that, I have x minus 4 left. So I set each of those equal to 0. 2x squared equals 0. X minus 4 is equal to 0. So 2x squared equals 0 just means x is equal to 0. You can divide by 2, take the square root, and still get 0. And then the other one is x equals 4. So this is the point 0, 0, and this is the point 4, 0. Yep. Oh, it was, darn. Bonus point. Man, I would like to say it was the first of the year, but Patrick got me earlier. Okay, so x minus 2 equals 0, and x equals 2. So we get 2, 0. So a bonus point for Olivia, write the name on the board. All right, go ahead and find the y-intercept. So plug in 0 for the x. What do we get? 0, right? Doesn't it make sense? Because we already have 0, 0. That's the origin. So the y-intercept is also 0. That makes sense. All right, the next one, x-intercept. Plug in 0 for the y. You get 0 equals the square root of x squared plus 4. We square both sides. We still have 0, so 0 equals x squared plus 4. We subtract the 4 over, and we try to take the square root. Writing plus or minus. But what happened? It's an I. It's imaginary, right? So we get plus or minus 2i. Is that an intercept? No. So when you get imaginary numbers, that's not going to be something that we can graph on the x-axis. Yeah. Good question. Yeah. Okay, so we get x equals plus or minus 2i. So you can just kind of cross that out. So there's no x-intercept when that happens. All right, the y-intercepts, though, maybe that happens. We'll see. So if I plug in 0 for the x, I get y equals the square root of 0 plus 4, which is y equals the square root of 4. What is the square root of 4? 2. Is it plus or minus 2? No, it is not. This is what we call a principal root. So if there is no sign in front of the square root, we assume that the sign that's in front of it is positive. Okay, we've already done the plus or minus thing. It's there. It's positive. So it's only positive 2. So it's kind of tricky. A lot of math teachers will mess that up. All right, so it's the point 0, comma 2. Yep. Like factor? It doesn't factor because it's the sum of 2 squares, right? The difference 2 squares work. Like if it was x squared minus 4, it would work. Yeah. All right, so it says sometimes you're going to be asked to write a quadratic function in what we call vertex form. So vertex form allows you to identify how much you've shifted to the right, to the left, up, and down. So an example of like vertex form would be y equals 3 times x minus 2 squared plus 5. Okay, do you guys remember back in the day we did math aerobics in Algebra 2? A very fun day. I'm not going to make you do math aerobics. You should. Totally fun. All right, so if I have 3 times x minus 2 squared plus 5, what direction horizontally has it shifted? Did it go right? Did it go left? And how much did it go by? It went to the right 2. Anything inside with the x does the opposite of what you think. So this one goes to the right 2, and then where does it go for the y value? Does it go up, down, how much? It goes up 5, exactly. So for this, we would go right 2 and up 5. That is in what we call vertex form, because we can tell that our vertex is at 2, 5, because we go right 2, up 5 to get to it, okay? So it's nice when things are in this vertex form because you can quickly see the most important point of a parabola, which is the vertex. So we do this by completing the square. You guys don't like completing the square. It's all right. So this is our vertex form. So f of x equals a times x minus h squared plus k. And the point h comma k is our vertex. So in order to complete the square, I wrote all the steps. You pull out a from the x squared term and also the x term. You look at the coefficient in front of x, you have it and square it. In other words, you divide by 2 and square the result. You add this number inside the parentheses and subtract the number on the same side. This keeps the teeter-totter even. And then you write the inside of the perfect square. So kind of confusing. Let's go through this. Hopefully you'll remember. Okay, so we have f of x equals 2x squared plus 8x plus 7. So what we're going to do is we need a 1x squared in order to complete the square. In order to complete the square, CTS. All right, so I pull out the 2, and when I do, I have x squared plus 4x. I leave a little space. When I do plus 7. That last number is always just hanging off on the end. It doesn't matter. It's the very end. Okay, I want to find the magic number that makes this so that it's a perfect square. So I want to find the number that I put right here to make it so that I can write it as something squared. So think about it. If I was trying to factor and I was trying to get the same thing in my 2 sets of parentheses, and I wanted the outer and inner to combine to be 4x, what number would go right here? Close. 4. Okay, because it's going to be, you're going to put the 2 here and the 2 here. That's what you're saying, the 2's go there. And then the last terms multiply together make 4. Okay, so Ben's already skipping ahead, I think. So we have 4 here. I guess I can ask it very clearly. All right, so I'm adding 8. Now, usually what we did in Algebra 2 is we then added 8 to the other side of the equation. But since this is in function format with f of x, instead of adding to the other side, we're just going to subtract from this side, which is kind of strange, right? Like, wait, why did I add and subtract? There's a purpose to this, I promise. All right, so I get 2, and then I do parentheses. I factor, so I have x plus 2 times x plus 2. So it's x plus 2 squared minus 1. It is now in what we call vertex form. So think about it. Can you identify what the vertex is? Where did I shift? Left 2, yep. Down 1. So it's negative 2, comma, negative 1. That's why in your vertex form, it's x minus h squared. It's minus h, not x plus h. Right, because it's the opposite number that's there. So if you had a plus 2, vertex form is going to be minus 2. Okay, so we're going to have negative 2, comma, negative 1. So right there. Does this parabola go up or down? Up, because it's a positive x squared. Are there any other important points that we know? How about the y-intercept? What happens when you plug in a 0 for x? What do you get? 7. So it's 0, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we can sketch our parabola. That's all we needed. Done. Okay, so same idea on the next one. So we're going to follow the same process. So we have f of x equals, we're going to pull out a negative 1 just from the x term. So I'm still going to have x squared, but now I'm going to have minus 6x, and that negative 8 is just off outside of the limit. And I'm going to complete the square. So think about it. Two sets of parentheses, what numbers do I need? What do they multiply to be? So I'm going to have it, so take the negative 6 divided by 2, negative 3, and square it. Negative 3 squared, 9. That's the number that goes here. I would say have it and square it. I used to write b over 2 squared all the time in algebra 2. That's what we're doing, b over 2 squared. All right, now what I really added wasn't 9. I really added negative 9. So how do I undo it? Plus 9, right? So I have negative 1, and then I factor into x minus 3 times itself, x minus 2 squared, plus 1. That is vertex form. What's your vertex? Yeah, you move to the right 3 and up 1, so 3, 1. Yeah. And that's why it's positive 9 there. Yeah. But then since you have the negative 1 times 9, yeah. All right, what's the y-intercept? Negative 8, exactly. So it's 0, negative 8. Make sure it is like 2, 4, 6, 8. Always see if it makes sense. Does this parabola go upwards or downwards? Downwards. Does it make sense based on the axis of symmetry? Yeah, when it goes downwards, that means we have another point over here. And we can draw it in. Oops. I'm not very good at drawing it in. Very good. Just like that. Good. All right, so the thing that I always hate about math textbooks is sometimes they have a really long explanation of things, and I'm like, really? Do we need to do it that way? I feel like this way is much easier. Okay, so I'm going to show you another way to do these, and you'll probably like it because I think that you probably don't like completing the square. However, I am going to say that completing the square is super useful other times. So when you do conic sections, like being able to complete the square is going to be very, very useful. All right, so don't just forget about completing the square completely. All right, so I'm going to do this example 1 in another way. So you can write it if you want to. You don't have to. You can just kind of pay attention if you want to. So do we know how to find the vertex without doing complete the square? What did I teach you? Negative b over 2a, right? So we're going to do negative b over 2a. So I'm going to say negative 8 over 2 times 2. So I get negative 8 over 4, which is negative 2. We then go and find what f of negative 2 is, which can sometimes be a little messy. But you're capable of doing it. So we get 2 times 4, right? Negative 2 squared is 4, times 2 is 8, plus a negative 16 plus 7. So what do we get? Negative 1. That means my vertex is negative 2, negative 1. Well, what is that? That's my HK. So if you at least have this memorized, a times x minus h squared plus k, which is kind of a hard one to memorize because you make those note cards like everything. You can memorize it. Right? That means that our h is negative 2, so I get plus 2. And my k is 1, so I have minus 1. The only thing I'm missing is a. So let's think about it. We just said that this vertex form was here. We're almost there. We just need a is equal to 2. Let me get that a. So think about the quadratic formula. In the original, so up here, 2x squared plus 8x plus 7. What's a? 2. It's not a coincidence that in this formula it's a. A is still 2. Okay, so that's what the a value is that they're talking about. It's the same as if it was the quadratic formula. So the last step is we say, well, it's going to be 2 times x plus 2 squared minus 1. So if you prefer to do that way and not complete the square, you can do that. That's fine. So it's up to you. All right, so number 2, it says write the vertex form of the equation of the parabola whose vertex is at 2, 3 and passes through the point 0, 2. So let's start out with our vertex form, y equals a times x minus h squared plus k. And we know that the vertex is at 2, 3. So that's going to be our h and our k. But in this case, we don't have the original. We can't tell what a is. We don't know a, b, and c, right? So this kind of goes back to what you guys learned when you were in Algebra 1. So in Algebra 1, when you guys were finding equations of lines and you didn't know what the b value was, the y-intercept, what we did is we used a point for our x and our y to find b. Okay, same idea here. You have that it goes through the point, so we're going to use that as our x and y temporarily. So just this one time, they're just going to be the x and y in order to find that a value, and then we'll just use x and y. So I get y was 2. So I'm going to have 2 equals a times 0 minus 2 squared plus 3. So I'm using that point to find a. I'm going to subtract my 3 over, so I get negative 1 equals a times negative 2 squared. So negative 1 equals 4a. So a equals negative 1/4. So now we have a, and we have h, and we have k, so we have everything we need for that vertex form. So I have a is negative 1/4, h was 2, k was 3. So that's our equation. And that's how we just have x and y in the final. We don't plug in 0 and 2 again. That's it. We just use it at one time. Okay. So number 3, it says find 2 positive numbers that add to be 110 whose product is a maximum. So whenever you see maximum or minimum right now, the only thing we know how to maximize or minimize is parabola. So we're probably going to have the equation of a parabola at some point. Okay, so let's write out what this is saying. So let's say we let x and y be the 2 numbers. So it's saying find 2 positive numbers that add to be 110 and whose product, x times y, is going to be maximized. So I'm going to write product equals x times y. So I'm trying to find the maximum of this product, but this product doesn't look like a parabola right now. I have x times y. I don't know what that is. Like, how do you graph x times y, right? It doesn't look like a parabola. Okay, but we can get it to be a parabola. So we're going to use this equation that we already had, the x plus y equals 110, and we're going to try to replace everything in the product so that we have only x's. You know what I'm saying? Then we do substitution. So how can I replace y? What can I put in for y? Yeah, Catherine? Exactly. So I'm going to say 110 minus, well, actually, x equals y, right? So 110 minus x equals y. So I'm going to have x times 110 minus x, which is 110x minus x squared, which is a parabola. Is it a parabola that goes up or down? Which one? It goes down because it's a negative one in front of the x squared. So it's a downward parabola. So we have product, so I'll say P equals 110x minus x squared, which is negative x squared plus 110x. You want to see it in the CMU form with the x squared first. So it's a downward parabola. So if we're finding the maximum or minimum of a parabola, we just find the vertex. So you can do the whole completing the square, but I thought that's kind of hard. Why don't we just do x equals negative b over 2x? So I get negative 110 over 2 times negative 1. So I get 55. 110 over 2. Okay. What's y then? It's 110 minus x, right, which is 110 minus 55. So it's really okay. It's 55. Yeah. It's usually when you're saying find the maximum of something, a lot of times it's a square, like the maximum area is usually a square. There can be weird things though that happen. So in this case, it was 55 and 55. Multiply those 2 numbers that are closest together, they're actually equal. The 2 numbers are 55 and 55, yeah. Yeah, I didn't say they were distinct, right? I didn't say they had to be different. I didn't say they had to be integers or anything. All right, and the last thing I want to show you, we'll kind of skip through here. You guys know the quadratic formula, hopefully. If you don't, I would be memorizing it. We did a couple with the quadratic formula, I think, already. But let's go ahead and we'll look at, like number 5 says, use the quadratic formula to find the X-intercepts. So if you're finding the X-intercepts, remember you're plugging in 0 for Y. So you're doing X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So we get 6 plus or minus the square root of 36 plus 44, so 80 all over 18. So in the instructions I said write your answers in both exact form, but also as approximate answers rounded to 3 decimal places. So we're going to simplify. So I have 6 plus or minus the square root of 80. Maybe you know the largest perfect square that goes into that. 4 times, oh, sorry, not, okay, 4 times 9. So what did I get? So what did you get when you added those? I just really wanted it to be 1, apparently. All right, so Julia gets the point. I need my calculator. So 432 again. So what goes into 432? Okay, it breaks into 16 times 27. So let's do 16 times 9 times 3. So what's the square root of 16? 4. So I'm going to have 4. What's the square root of 9? 3. And then I still have a root 3. So I'm going to have 6 plus or minus 12 root 3 all over 8. When you look at the little 6, 12, and 8, you make your beautiful heart. All right, they're all divisible by 18. I knew they were all divisible by 6, I just wasn't ready. Okay, so 6, 12, and 18, so divide by 6, so you get 1, 2, and 3. So 1 plus or minus 2 root 3 all over 3. Right? So then your approximate answers. So I'm going to have 1 plus 2 root 3 all over 3. So when I find the decimal answer, I get 1.488. And when I do the other one, 1 minus 2 root 3 all over 3, I get negative 0.821. So this is the exact form. These are the approximations. Stop there. All right, so the next one is we multiply the x minus 1 times itself, and then distribute the x in. We're going to have 3 times x squared minus 2x plus 1 minus 4x minus 8 equals x squared minus 5x. And we continue to simplify. So 3x squared minus 6x plus 3 minus 4x minus 8 equals x squared minus 5x. Then we get everything on one side. So we have negative 10x. When I add the 5x over, I get negative 5x minus 5 equals 0. And we try to factor, so we get 2x and x, and we have 5 and 1. But as you can see, there's no way to get our results. So you can switch the 5 and the 1 and have 1 and 5. Can't remember which way I had it now. And it doesn't work. So either way, it does not factor. So we have to do the quadratic formula. So we do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get 5 plus or minus the square root of 25 plus 40. So we have 65 all over 4. So we have 5 plus or minus, I don't think it actually 65. I'll break down me further because 65 divided by 5 is 13. So that's as far down as that goes. So that would be your exact answer. And your approximate answers you do 5 plus the square root of 65, and then divide by 4. So the first one is 3.266, and then if you put minus in between, you get negative 0.766. These are two approximate numbers. All right, so the next one says, where do these intersect? So if a parabola is intersecting a line, it's basically the same way we found where things intersected, where two lines intersected, and now it's two. So it's basically a system of equations. This is what we're saying. And you're going to replace this y with what y is equal to. So you're doing a substitution method. So you're going to have negative x minus 1 equals negative x squared minus 3x plus 4. And you get everything on one side. So you have x squared, you add the 3x over, so you get plus 2x. You subtract the 4 over, so you get minus 5 equals 0. And then you can use the quadratic formula, so negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 2 plus or minus the square root of 24, which is 2 root 6 all over 2. So x equals negative 1 plus or minus root 6. So if you find those as approximations, you get 1.449. And the other one is going to be negative 3.449. Okay, but then if you're really trying to find the point, so you actually have to plug those numbers into the negative x minus 1. So if you have the calculator where you can grab it, go back up and grab it, or you can store values. Remember, we talked about storing a lot last year. So the y value that goes with this first one is negative 2.449. And for the other one, you get negative 3.449 is the x value, and the y value is 2.449. Okay, so those are our two solutions. Okay, so it does say you can verify with a graphing calculator. Basically, if you're going to verify with a graphing calculator, let me go ahead and open the lab it thing. So you can go to y equals, and you can put in both things. Oops, I still have mine set from a Precalculus, and change it to function notation instead of polar coordinates, which we'll talk about later this year. All right, and I'm going to hit y equals, and we're going to put in both of those equations. So the first one was negative x raised to the 2. Oops. Let's do this. Negative x squared minus 3x and then plus 4. And then the other one is negative x and then minus 1. Okay, so when we hit graph, you can see that we have our downwards parabola, and then we have a line intersecting it. So if we want to find both of these intersection points, all we do is we do second, trace, and we would go down to intersect. And when we trace using this cursor, we want to hit enter. And then along the second curve, hit where you think it is and hit enter again. And then hit yes. So we have the intersection point that we just found. And you can do that for the other one as well, and it works exactly the same.